I record several videos about the criteria for estimators, and today is about the unbiased estimator. Let's assume a parameter of population mu, and mu equals 6. Just to see this vertical green line. If you are a classical statistician, the parameter is a constant. That's why mu equals 6. And it's just to highlight that it is the true parameter of the population. Let's call this mu star. Use the star to mark this is the true value of the parameter. If you are a Bayesian statistician, you can think that the parameter is a random variable that has a normal distribution. For this exposition, really doesn't matter if you think that the parameter is a constant or a random variable. Suppose now that I go to the population and I extract samples, but not a random sample, a kind of biased sample. The blue normal distribution curve represents the samples that I extract from the population. If I average all the samples, I get mu hat equal 8. It is this vertical purple line. The data suggests that the parameter of population is 8, but we know that the true value is 6. What is bias? Bias is this orange line. In Econometrics, the first criteria to get an estimator, you want an unbiased estimator. I would say that for economists, this is an absolute criteria. In machine learning, you accept bias because you want a lower variance and then improve the forecasting. But for econometrics, if you care about causality, you want an unbiased estimator. Now you know why economists are so obsessed about the asymptotic properties of the estimators. That means what happens with the estimator when the sample size increases to infinite. If you study the PhD book from Utrecht, you will see that half of the book is about to prove the asymptotic properties of the estimator, derive mathematically that the estimator is unbiased. If you are applied research, you need to know how to avoid bias, how to mitigate bias, but you don't need to derive mathematically prove that the estimator is unbiased.